Okay, I'm going to talk you through a couple more of these problems involving algebra, and I'm going to start you off by having you write something at the top of your page. You've probably seen this on the board a few times. We're going to jot down 2 thoughts. With these problems, we might be setting things equal, or we might be adding 2 things and setting them equal to a third thing. Keep that in mind as we work through these. First thing we're going to do is start with a picture. M is the midpoint of EG. So you should already be drawing on your page. EG, M's the midpoint. I'm going to make a good habit of marking my picture. Whenever I read that word midpoint, that means that M is not just somewhere between E and G, but exactly in the middle. So I'm going to mark it with those tick marks to indicate that. And I now know that EM is equal to MG. So something to keep in mind. Let's go ahead and put our expressions on there and see what we've got. EM is 7x. MG is 8x minus 6. And that's all the given information that I have. So just looking off of that, I would be tempted to say that we're going to go with the equation that we see on the left-hand side at the top here, where we're actually setting things equal to each other. Because we only have 2 things, versus the one on the right-hand side, we're going to need 3 parts to it. So that's what I'm tempted to say. However, I got to make sure that I know that's true. I've got to have a part is equal to another part. And I would know that if I have something like the word midpoint or bisects. Recall, we did have the word midpoint. We marked equal parts in our picture. So in this case, I am good to go ahead and say that those 2 parts are equal. That's what I mean when I use the word midpoint. So I do have the part on the left is equal to the part on the right. My algebraic equation is all set up, and I'm actually going to solve it right there. Go ahead and find the value of x. I'm going to subtract 8x from both sides. Some of you might have been tempted to subtract 7x because then you're keeping a positive x value, which I agree, I like that idea, but it actually leaves me with nothing on the left-hand side. And since I have a number on the right-hand side, getting rid of the 8x allows me to go ahead and get to my answer a little bit quicker. Okay, be careful, you do have a negative 1x on the left-hand side. You're not done because we want to get a positive 1x, so I can get rid of the negative 1 by dividing by a negative 1. Negative 1 divided by a negative 1 is a positive 1. Negative 6 divided by a negative 1 is a positive 6. So I'm getting an x value of 6. We have solved the algebra equation, but we're not in algebra class. We are in geometry class. So let's do the geometry. Geometry question, if I go back to the top, tells me to find EG is what I'm looking for. So I've got to find the length of EG. Looking at your picture, that's posing a little bit of an issue for me because EG is the whole thing, and I don't actually see any expression that's referring to EG. So what I'm going to do is I'm going to find what I can find. I'm going to ignore the question, and I'm going to say, hey, wait a second. I know that EM is 7x. So if EM is 7x, it's 7 times. We just found that our x value was 6. So I'm going to plug in a 6 right there. And I'm going to keep going. Multiply that out. 7 times 6, I'm getting 42. So that part right there is a 42. I also have this nice expression for mg, so I'm going to use that. Mg is equal to 8 times x minus 6. My x quantity I'm going to go ahead and plug in was a 6. 8 times 6, grab your calculator or do it in your head. 8 times 6 is 48 minus 6, and I'm getting a 42 for that as well. Good thing, because those 2 parts were supposed to be equal. If I got something else, I must have done something wrong, and I'm going to have to go back and check my work. I did get 42, and at this point, we should be able to visually say that EG, the length of the entire segment, is really just the sum of those 2. It's EM plus MG, which is my 42 and my other 42, giving me a total of 84. If you got that a little quicker, that's great. The other way you can do it is just add them up right here, and we're getting 84 for the length of EG. pretty simple. I like those ones where you can just set things equal, don't overthink them. If you have the two parts, set them equal to each other. Let's look at one more example. Okay, I'm going to throw something else at you this time. I'm going to use the word bisects instead of midpoint. But let's go ahead and remind ourselves of our two options here. I can set two things equal, or I can add two things and set them equal to the whole thing. Words I like to put in here: part is equal to part, or part plus part is equal to whole. Let's give ourselves a little more room there, and let's work through this one. PQ bisects ST at W. Really important that you get a good picture for this one. Okay, I like to start with ST. Actually, the one that is being stated after bisects is the one that's being cut in half. And let's draw that first, sort of on the horizontal there. PQ is bisecting it, which means it's cutting in half. I don't care where P and Q are. It tells me W is the point of intersection. And what I care about is that we identify which parts are equal. ST is what's being cut in half. So ST is my segment that now has two equal parts. SW is equal to WT. That's where your tick mark should go. Okay, let's get everything on our picture, and then let's figure out what we can do with it. I've got TW is equal to 6x minus 7. The segment right there. I've got ST is equal to 8x plus 10. Be careful, look at your picture. ST is not the other part. ST is actually all of this, what I would refer to as the whole length of that segment. Whereas to find SW and ST, I don't really care about that right now. What I care about is I have to come up with an equation that relates the two expressions I just wrote down, the 6x minus 7 and the 8x plus 10, and it has to be true. So the first thing I'm going to think is I have two things. I would love to set them equal to each other. Can I go ahead and use my part equals part and plug stuff in? Well, it looks like the part on the right-hand side, the WT, is 6x minus 7. So I could go ahead and put that in there. But then I have to have something on the other side, and it doesn't look like I have the length of SW. All I have is 8x plus 10. So if I put 8x plus 10 there, just for fun, let's look at it. What I just said in this equation, what I'm saying in this equation is I'm saying that the length 8x plus 10, which is what I have on the left-hand side, is equal to the length 6x minus 7, what I have on the right-hand side. Visually, does that make sense? That the whole thing is equal to one part of it? Absolutely not. Makes no sense at all. Which is why I say it has to be part equals part. So I hope I didn't just confuse you on that. But I wanted to show you, because a lot of times we just like to set things equal, that we cannot put that in there. We have to stick with knowing the two parts in order to set things equal to each other. And at this point I'm stuck. I don't know what the other part is over here. That's an unknown. So I'm going to have to go to some other option. Maybe I can use the equation on the right-hand side because I have part plus part equals whole. And we just established, hopefully, that that's the whole. So I could put that in on the right-hand side, the 8x plus 10. And let's see if I can fill in the rest of it. I need two parts for the left-hand side. But it looks like I've got one part is my 6x minus 7. Do I have something for the other part to add to that? And I'm still stuck on I need to know what SW is. But at least now I'm using the 8x plus 10 appropriately. Do I have anything I can say about SW? There's no given information about it. But I did mark something in my picture that could help us out here. I marked tick marks, and that tells me things are equal. So if SW is equal to WT, then whatever WT is, SW has to be the same thing. Which means I can now say that SW is actually going to be 6x minus 7, because it's the same as WT, and WT was 6x minus 7. And there's your answer. or your answer for setting up the equation. There's your missing part. The other part is the exact same as the part that you have. Because you're told that we have a bisector, we know the two parts are equivalent. So I now have a good working equation. I'm going to go ahead and bump this equation down here so that I have something that I can solve. Just a real quick note, you could have set this up slightly differently. If you were thinking along the lines of 2 times the quantity 6x minus 7 is equal to 8x plus 10, that would have been fine. Alternatively, you could have done 6x minus 7, the one part is equal to half of the entire quantity, 8x plus 10. Either one of those would have worked. Just make sure you're using the parentheses appropriately. I'm going to stick with the one I first wrote down, and I'm going to do the algebra to solve that. You solve your equation. We'll see if we get the same answer. 6x plus 6x, I need to combine like terms on the left-hand side. Minus 7 minus another 7 gives me a minus 14. Keep the right-hand side the same. And I've now got variables on the left and right, numbers on the left and right. Let's do it one at a time. I'm going to do my variables first. Subtract 8x from both sides, giving me a 4x on the left, minus 14 still equals 10. Add 14 to both sides, giving me a 4x on the left equals 24. And my final answer for x, for the algebra problem, is x equals 6. But I'm not done because I'm in geometry class and I've got to solve the geometry problem. All I know is that the value of x is 6. Let's go back and read the question. I'm going to erase these just to clean things up a bit. Question reads, find SW and ST. At this point, I should be able to find anything I want because it's all right there in my picture. I've got expressions for everything. So I'm going to start with ST, which is down here. 8 times my x value, which was x is 6 down there. I'm going to go ahead and bring that up, plug that in. 8 times 6. In my head, I'm getting 48 plus 10. 58 for my answer of ST. Now I've got to find SW, and we said SW is equal to WT, so it doesn't matter at this point which one you plug it into. We have the same expression there. 6 times the quantity of x, which again, x was 6, so I'm going to bring it up here and use that again, right here. Minus 7, 6 times 6 is 36. Minus 7, I'm getting 29 if I'm doing my math correctly on that part. So we've got SW is 29, ST is 58. Real quick, we should notice that SW is actually half of ST because that was a midpoint. So 58 divided by 2 is giving me 29. That's another good quick check that you can do. Final answer is over there. We sure did a lot of work to get that. Be careful with your algebra, but most importantly, make sure you have a good picture for these and make sure that your setup is correct. Really focus on my 2 ways of setting up these equations so that you make sure you get a correct equation. Then we can work from there and tackle the algebra.